problems that you can count on. There will be Bode plot problems. There will be at least one complex pole or complex zero Bode plot draw it problem. That is guaranteed. There may be more than one. There will be a Bode plot where you have to take a transfer function from the Bode plot. You find your test? Yep. Good. Just haven't checked your folder in a long time. There will be a problem where you have a Bode plot and you will have to take a transfer function from that Bode plot. So let's see. Draw Bode. 1 or 2. Bode to a plant transfer function. You'll get one of those for sure. Bode, GM, PM, DM. Virtually assured, okay? Nyquist. 1 to 3, 2 or 3, put it that way. 2 or 3 problems there. Z transforms. Particularly the relationship am I doing that right? Between Z plane and S plane. Then also make sure that you can go from a difference equation and a block diagram and a transfer function in Z. But since we haven't done a heck of a lot in any of those kind of problems would be on the simple side. So, simple points.
Simple right shift, left shift type stuff.
Yeah. And remember that if a block diagram shows this kind of a part, z to the minus 1, and this kind of a block, what is the difference between these two? They are the same. Same thing. So either way, you can interpret it the same way. The delay is typically used if the block diagram is an input, a time input, and a time domain outputted. If you have a z input and a z output, generally use the z to the minus 1, but you can use them pretty well interchangeably. All right, and I think what I'll do at this point is open it up to questions. As far as anything else that may be on the exam, anything from previous tests and such, anything from the entire semester is fair game. I do look at old exams and look for problems you did badly on, and sometimes hit those again. Things that are, if I do something with root locus, it will probably have something to do with angles, like a departure angle problem or a design problem, because that's about where you start to really have trouble with those root locus plots. Mechanical analogy. If you look at some of the old finals, they're on there. If I do something, it'll be very simple. Let's see. Beyond that, we could do transfer functions and inverse Laplace and all that sort of stuff with the Laplace domain, but most likely I would do that in the Z transforms. One of the reasons that I can weight this test heavily toward the Z transforms, even though it's just the last couple of days, is because there is so much overlap between the Laplace transform stuff and the Z transform stuff. So I don't have to necessarily go back and do some of that stuff. I don't have to go back and say, what do all these signals look like in the time domain versus where are the poles on the S plane. I can kind of do something similar in Z transforms, and you have to make that one extra step of the analogy. So if you know where to find the poles on the Laplace S plane, then you also know where to find them on the Z plane. And that's, so I can give you a problem for the Z transforms where I give you signals and say, well, where are these poles? And it's basically asking you a similar sort of question in Laplace, but with one more step. So that's kind of why I can put quite a bit of emphasis on that, because there's so much that has just another step in it that works out. All right, so let me open it up for questions. Yes?
Do you have any review sheets left?
Yellow review sheets, or the yellow cheat sheets for the
Yeah,
test?
cheat sheet.
Yes, I do. Is there anyone who still needs one of those? Do you have the exam study guide? Okay, so there's still more of these left. Yes?
Can we do spring 13, number 5?
Spring 13, problem 5.
Open book. The open book part.
Yeah, well, there was an open book part.
Or,
Yeah.
sorry, what is it?
Spring 13, problem 5.
Go back to problem 1.
I am expecting most of your grades to go up with this final. Or a lot of them to go up. Because this final, if I concentrate on this last stuff,
Me too.
of course my expectations and what really happens are not always the same.
You did make it.
Spring 13, problem 5. This, yeah, it's not that complicated. It's going to take me a second to draw this.
Oh no, this is not the one.
Oh, I'm looking at 6. He's looking at this one right here.
With all the,
He's looking at Nyquist's problem.
oh no, it's all these plots here.
The
So-
plots for the Z
There's two
transform.
number 5 from that exam.
Yeah.
Oh, the
Yeah.
5 closed book, 5 open book.
It's got all the Z transform and then the unit circles on the right hand.
All right,
Yeah.
good.
Yeah.
So this is time domain here, or discrete time domain. So this is K out this way, and we've got a number of signal. This does something like that. So these are the different points of the different K values. Let me ask you this. If it was a straight line down like this in the time domain, where would that pole appear on the S plane?
Right here.
Where are we having a pole? At the origin. Just one? It would be a double pole at the origin. We would have a double pole at the origin. So if I do that in the, like this, in the Z plane, it's not that straight line anymore, it's all these individual points. Where are the poles? Or what's the analogous point to this in the Z plane?
At the 1. So double.
So what are you expecting at the 1 point?
Double. Pull.
Double pole there. So this is what I'm talking about, that this is asking questions essentially about both, right? So, next one. Oops. Let's do the 0 up here because it's doing it down like this. So you look at this and say, what does this look like? Where is it on the S plane for the straight line? What would it look like? What kind of poles do we have? There's a step. So I need a pole where?
At the origin.
And what else do I also need? Just to the left. So on the Z plane, what's the analogous place?
At
Or places? There's one right here, and what else?
Wait, close.
Like that. Okay, see how this is, in a way, it's asking about both. Because that's the kind of what I expect you to do, because you should be really familiar with that. and a little bit less familiar with the Z-plane, so you kind of play with that a little bit. Do it in a sort of a two-step process. The next one is, okay, this is going to be a hard one for me to draw and get it right. So if we had a signal like that, and where would the poles be in the S-plane? In time domain, where would the poles be in the S-plane? So we have an exponentially increasing sinusoid. Where do you think they are, Brian?
I don't wanna say, cause it might be wrong.
Now there is the vision of self-confidence. Try anyway, Brian.